Today we are going to be doing lesson 1.1. All right, now this is solving simple equations. So a lot of this you're going to see today, you're going to think, Miss Johnson, you can go faster through this. I'm good. I know how to do this. All right, but one thing I want you to understand with me, all right, there may be certain things that you've learned before, and I may teach them exactly like you've learned them, and you're going to be like, this is a piece of cake, I'm good to go. But then there could be things I teach, and maybe I teach it a little different than you've heard before. Maybe something I say helps a concept click with you. All right? So one thing I don't want you to do is I don't want you to ever start working ahead of me. Because if you start working ahead of me, you might miss something super important that I tell you as I'm going. And I don't want you to miss out on a tip or a trick or a shortcut or something that I may teach you. All right? And it's going to be especially tempting today just because this is a simpler lesson. You've been learning simple equations for a couple years now. So I just want to say, stay with me. All right. Another thing you're going to notice is that sometimes I add notes to the notes I've already given you. If I add something up on the screen, it's not a bad idea for you to add it to your notes as well. Maybe you're like me and you hear something once, but until you practice it or see it again, it doesn't really stick. So if I add something to the notes, go ahead and add it. Another thing I want you to know is anything I put on the screen needs to go in your notes. Okay? Because what I put on the screen is what I'm looking for in homework, quizzes, and tests. Now, occasionally you'll hear me say, we're doing this in our notes. You do not have to do this on quizzes and tests and homework. Okay? But 95% of the time, the work that I'm putting in the notes and the things I'm putting on the screen are exactly what I'm looking for to give you credit on homework, quizzes, and tests. So whatever I put on the screen, even if you think you don't need it, put it in your notes. All right, so those are just a couple things because this is the first time I've taught you, so I just wanted to make sure you understand. Now, the first thing you're going to see at the top of your notes and every day in the lesson is an essential question. Okay, I will abbreviate it to EQ, but it stands for essential question. This is the question that we're hoping to answer by the end of the lesson. Today, the essential question is, how can you use simple equations to solve real life problems? How many times have you asked someone, when am I ever going to use this in real life when it comes to math? Well, hopefully by the end of today, you're going to see how simple equations can be used in the real world. Now, equation. I believe I left the entire definition blank because I want you to write the entire definition down. It is a statement with two expressions that are set equal. A statement with two expressions set equal. Now, an equation is a math word, but within this definition, there is another math word. It's an expression. Does anyone know the difference between an equation and an expression? All right, what if I ask it this way? What does an equation have that an expression does not have? Okay. What if we look at the first four letters in the word equation? What are the first four letters in the word equation? E-Q-U-A. All right, and look at the definition. It says a statement with two expressions set equal. What are the first four letters of the word equal? E-Q-U-A. So what do you think an equation has that an expression does not?
Equal sign.
An equal sign. Very good. Very good. So an equation has an equal sign. An expression does not. A mathematical expression does not. So an expression would be something like 2x plus 2, right? 2x plus 2 doesn't have equal sign. It's got numbers, variables, and operations, but it doesn't have equal sign. What if I just said 2x? That's an expression. There's no equal sign. But the minute that I say 2x plus 2 equals 12, now I've written an equation. So an equation has an equal sign. Now, there are two steps to solving an equation. First of all, we're going to find the number that's keeping the variable from being alone. Now, once again, here's another math word that you should know. Does anybody remember what a variable is? Don't be shy. Even if you get it wrong, at least you tried. Maddie? It's a letter in your math problem, all right? So variable. So we are trying, the whole point of solving an equation is to get the variable by itself. So we are trying to get the variable by itself, which means we have to find the number that's keeping the variable from being alone. Then, step 2, we have to move that number to the other side of the equation with an inverse operation. So here again are some math words that you are hopefully familiar with. And look at example 1. they want us to state the inverse operation. So before we ever get into solving equations, we're going to review what an inverse operation is. Now, you can see the definition I've put up there and fill in the blanks in your notes, but it's operations that undo each other. Now, before we even talk about these operations, let's just talk about life for a second. Okay, not even really, this is still math related, but what is the opposite of even? Odd, right? They're opposites of each other. If I ask you for the opposite of positive, you would tell me it is negative. So inverse operations are operations that are opposites of each other, right? What are the 4 basic operations in math? Beautiful. Add, subtract, multiply, and divide. So addition can be undone by which of those other operations? Subtractions. They're opposites of each other. And then multiplication can be undone by division. All right? So these are our inverse operations. So you see in letter A, if they are adding 28 to a problem, what is the inverse of adding 28? Subtracting. So all I'm asking you to do is just minus 28, and then you can box in your answer. All right, if they're subtracting 15, what's the inverse of subtracting 15? Adding 15. So plus 15. Now, letter C. They are multiplying 7. When you multiply, what is the opposite or the inverse of multiplying? You are dividing. All right, and for right now, we're going to use the division symbol. You'll see later on we use something different. But for this, we're going to do divided by 7. All right, letter D. They're dividing by, now what kind of 17 is that? Negative. I'm sure you've heard this before, but you will hear me say this over and over. Every number has a sign, and the sign is directly in front of it. So that is not a 17, that is a negative 17. So if they're dividing by negative 17, what's the inverse of that? Multiplying by negative 17. Very good. We don't change the sign. When we're multiplying and dividing, when we're using multiplication and division as inverse operations, make sure you do not change the sign of the number. The only reason the signs changed in A and B is because we were going from addition to subtraction. Okay? Does that make sense? When you're using multiplication and division as your inverses, do not change the sign. Now, you'll notice something else. I don't use the X for multiplication anymore because I don't want you to be confused between multiplication and the variable X. So I either use a dot or I use parentheses. And we're going to use a dot for right now, even though I know it looks a little bit silly. It's all right. So multiply by negative 17. The inverse of dividing by negative 17 is to multiply by negative 17. Now, example number 2 says solve the equation. Here's the next thing you're going to notice about me. Whatever the directions in the notes, they should match what you see in your homework that night. I try to keep it very similar, so you can use your notes at night to look back and see what we did in class. So, solve the equation. Now, remember, to solve an equation, we have to get the what by itself? What's the variable. The whole point of solving an equation is to isolate the variable. So we are going to find and circle the variable in our notes. Now, this is one of those things you do not have to circle the variable on your homework, quizzes, and tests unless you want to, but we are going to do it in our notes just so we can make sure everybody is on the same page. All right? So letter A, what is the variable in letter A? N. All right? So I want everybody to circle the N. Now, what's keeping N from being by itself? The 3, the positive 3. So we're going to move it to the other side. How do we move a positive 3 to the other side? We subtract that 3. Now, would it be enough for me just to put minus 3 right there and then try to work the problem? No, because we learned a long time ago what we do to one side, we must do to the other. So we have to subtract 3 from both sides of the equation. When we're talking about both sides of the equal sign. All right? Now, what is 3 minus 3? 0, okay? Unless 0 is the only thing on that side of the equation, I'm never going to bring a 0 down. So I'm not bringing 0 down because what's left on the left side of the equation that I need to bring down? The n. All right, so just, again, one of those things you probably already knew, but I'm just making sure you remember it. Do not bring a 0 down, just bring the variable. Now, don't touch your calculators yet because you should be able to do this without a calculator. What do you notice about the numbers? We have a negative 7 minus a 3. So what do you notice about the signs of those numbers? They are the same. And what's the rule? When our signs are the same, we add and keep. So what's negative 7 minus 3? Negative 10. We added the 7 and the 3 to get 10, and we kept the negative sign. Now here's the beautiful thing about equations. We can always check our answers. Now I'm not going to make you, but it is something you can do, especially if you really want to be sure that you got the right answer. But remember, I can take my answer, that negative 10, and I can plug it back into that original problem, and I can see if it works. What's negative 10 plus 3?
Negative 7.
Does negative 7 equal negative 7?
Yes.
Then it checks out, okay? So just an extra thing for you, if you really want to make sure, especially on quizzes and tests, that you have the right answer, you can always take your answer and plug it back into the original problem. All right, moving right along. Letter B, what is the variable that we're trying to isolate?
G.
G. What's keeping G from being by itself? Negative 1/3, okay, or minus 1/3. They're the same thing. How do we get G by itself? I heard it. Add 1/3. Remember, what we do to one side, we must do to the other. What's negative 1/3 plus 1/3? 0. So we just bring the G down and it equals. Now, just because we see a fraction does not mean we need to panic and grab a calculator. What do you notice about your denominators here? They're the same. So this is a simple addition problem, except for the fact that your 2 is negative and your 1 is positive. So now my signs are different. What's the rule when your signs are different? Subtract and take. So we subtract the numbers. What's 2 minus 1? 1. And we take the sign of the bigger number. So which number is bigger, 2 or 1?
Negative.
Hold on. Which number is bigger, 2 or 1? 2 is bigger, and its sign was negative. So we take the sign of the bigger number. So G is equal to negative 1/3. All right. Take a minute and work letter C on your own. If you need to grab your calculator, you can, but take about 30 seconds, work letter C. All right, what's the variable in letter C?
Y.
And what's keeping Y from being by itself?
0.28.
2 and 8/10. So how do I get Y, or how do I move the 2 and 8/10? Subtract 2 and 8/10 from both sides. So these cancel. I bring Y equals down. What is 9/10 minus 2 and 8/10? If you need your calculator, that's fine. Okay? Not 2.1.
1.9.
All right, be careful though. What kind of 1.9?
Negative.
Negative 1.9. Now, some of the stuff I'm going to ask you to do is simply preference. My preference is that your final answer has the variable first. It doesn't make that answer wrong, all right? Hold on. So this answer is not incorrect, but I prefer your final answer to have the variable first. So we're just going to rewrite this and say Y equals negative 1 and 9/10. And that's what we're going to box in. So again, this is just my preference. I'm not saying that the answer is wrong right here, but before you box in your final answer, make sure you write your variable first. Go ahead and work letter D. All right, Faith, what's the variable in letter D? X. What's keeping it from being by itself? And how do we move the 3 to the other side? Good. They're subtracting 3, so we are going to add 3. These 3's cancel. Negative 3 plus 3 is 0. So X equals negative 2. Very good. Again, the signs were different, so we subtract and take. 5 minus 3 is 2. 5 is bigger, so we take the negative sign. Are there any questions so far? All right, moving right along. Still example 2, same directions. We're still solving the equation, but now we're looking at multiplication and division undoing each other. All right, did you notice the first 4 we were adding and subtracting to undo? All right, so look at letter E. Now, right off the bat, let me tell you a mistake I see all the time. Someone sees negative n minus 5, so guess what they do? They add n over 5 to both sides. Okay, but that's why you got to slow down and you got to think. What's the variable that we're trying to isolate? N. Okay, so I'm not moving the n. I need to move the 5. But be careful. There's a negative sign in front of our fraction. So here's the next thing you need to remember. I can assign that negative to either the numerator or the denominator. It does not go with both. It goes with either the numerator or the denominator. So tell me, which makes the most sense? Would I put it up there with the n, or would I put it down there with the 5?
5.
Why would I not put it with the n?
That doesn't do anything.
Well, you'd have a negative variable, and will you ever have a negative variable in your final answer? No, so you're just creating more work for yourself if you put it with the variable. So let's rewrite the fraction and let's do n over, and let's put the negative or the 5 down with that. Sorry, let's put the negative down with the 5. Now you've heard me say something a couple times that I actually don't like at all. I keep saying n over. All right, actually when you're looking at a fraction, what type of a problem are you looking at? A division problem. So this is actually n divided by negative 5. A lot of times when you're solving equations, if you don't know how to read it, you're not going to know how to solve it. So reading it is half the battle. So this is n divided by negative 5. Now go ahead and circle the n again because we already said that's what we're trying to isolate. What do we need to move so that n is by itself? Negative 5. And how are we going to move it to the other side?
Times.
Multiplication. They're dividing the negative 5, so we are going to multiply. So here again we have we're going to use our little multiplication dot and we're going to multiply both sides. Now, so far things have canceled and equaled 0, right? Negative 3 plus 3 was 0. But this is negative 5 over, if we wanted to make that a fraction, it would be over what? Or divided by what?
5.
No, how do you make a whole number into a fraction? You put it over 1, right? So, do you see how you have a negative 5 in the numerator and you have a negative 5 in the denominator? So, anytime you have a number divided by itself, what does it equal?
1.
1, right? It equals 1. So in these particular problems, we are still going to be canceling out that number, but we still don't need to bring the 1 down. We just need to bring the variable down because there's an understood 1 right there. So it is not necessary to bring the 1 down. So n equals, we've got negative 3 times negative 5.
15.
A negative times a negative equals a
Positive.
positive. So n equals 15. Awesome. All right, look at letter F. Aiden, can you read letter F for me?
Mike, did you read that?
Just read it.
1.3z equals 5.2.
All right, now, he said 1.3z equals 5.2. Again, half the battle is reading it. He has a number and a variable that are side by side. So what operation is actually happening here?
Divide.
A number and a variable side by side with nothing between them is multiplication. All right, so actually this reads 1 3/10 times z equals 5 2/10, which means, what is the variable that I'm trying to isolate? And I have to move what to get it by itself? 1 3/10. And how do I move it to the other side? Divide. I have to understand that they're multiplying so that I understand the inverse is to divide. Now watch. I do not use the division symbol. I use a fraction bar. Division symbol is just too much. So when we divide both sides, we're going to use a fraction bar and we're dividing both sides by 1 3/10. Now again, you got 1 3/10 over itself, which equals 1. We just bring down the z. And what is 5 2/10 divided by 1 3/10?
4.
4. Very good. So z equals 4. Now, I want you to take the next 30 seconds and I want you to work G and H by yourself. Riley, letter G, what's the variable that we need to isolate?
G.
And what was keeping it from being by itself?
5.
And how did you move it to the other side?
Times G by
Good. It was 5 times G, so we have to divide both sides. So the 5's cancel, and G equals what?
4.
Beautiful. All right. Caleb, what's the variable we're trying to isolate in H? And what is keeping it from being by itself?
7.
And how do we move it to the other side?
Multiply.
Good. Remember, if we read the problem, it's negative 7 equals t divided by 7. So the inverse is to multiply by 7. These 7's cancel. Remember, that's a 7 divided by a 7, so that's 1. And t equals, what is 7 times negative 7? A positive times a negative is a negative. So Caleb, what's 7 times negative 7? Negative 49. Now again, preference. Let's switch it. T equals negative 49. And then we'll box it in. Are there any questions? All right, moving right along. We are still in example 2. We are still solving equations, but now look at the numbers that we need to move. All right, to move a fraction, this says multiply both sides by the reciprocal. Well, first things first, what's a reciprocal? if I give you the fraction 1/2, what is the reciprocal of 1/2? What is it? 2 over 1. You simply take the fraction and you flip it, right? That's a reciprocal. You take the fraction and you flip it. All right? What if I were to give you -6? You say, well, that's not a fraction. Actually, it is, because I can put it over what number? 1. So what would be the reciprocal of -6 over 1? Careful.
Negative 1 over 6.
Okay? 1 over -6. All right? You do not change the sign, right? You take the fraction and you flip it. We're not talking about the opposite. We are simply taking the fraction and we're flipping it. So 1 over -6 would be the reciprocal. Now let's talk about something else when we're looking at these reciprocals. If I remove the little arrow and instead I put a little dot right there, when you multiply a fraction times its reciprocal, what does it equal? It equals 1, right? Because 1 times 2 is 2. And then down here, 2 times 1 is 2. So you'd end up with 2 over 2, or 2 divided by 2, which is 1. All right, so keep that in mind because that will be important in just a few minutes. Now, you got to be very careful with fractions, because if you're not careful, you will try to add and subtract fractions to both sides when really you should be dividing them on both sides. All right, so again, you've got to read the problem. Lydia, can you read letter I to us? All right, be careful. Give me the operation. I just didn't hear an operation in there. So 10 equals -2/3. There's nothing between the 2/3 and the m. So what operation is that? Multiplication. So how would we read it? So 10 equals -2/3 times m. Again, I've got to recognize that this is a multiplication problem. So technically, if they are multiplying by -2/3, what are we supposed to do to move it? What's the inverse of multiplication? Division, okay? But I want you to go all the way back to elementary school for just a minute. When you learned how to divide fractions, did you ever actually leave it as a division problem? No. You had to keep, flip, and change, right? KFC, you had to keep the first fraction, flip the second fraction, that's the reciprocal, and you had to change it to a multiplication problem, right? So I'm teaching you a shortcut. Instead of dividing both sides by -2/3, we're going to skip all the stuff in the middle, and we're just going to multiply both sides by the reciprocal. So go ahead on both sides, put your little multiplication dot, okay? And actually, the question is, what is the reciprocal of -2/3?
3 over 2. I get -2.
All right, negative. We got to keep the negative. Doesn't matter if it's with the 2 or the 3. So we're just going to say -3 over 2. Okay, I'm so sorry I didn't leave myself enough space. But over here, -3 over 2. Now, we already talked about the fact that a fraction times its reciprocal equals 1. So you can go ahead and cross the reciprocal and the fraction out and just bring down the m. Now, be careful over here. Don't grab your calculators. We can do this without a calculator. Again, the whole number 10, I can put it over what to make it a fraction? A 1. Now, you've learned this. Simplify before you multiply. You don't have to. You could just multiply and then simplify. But do you see a numerator and denominator here that will simplify before we ever multiply? What is it?
10 and
2 and 10, right? What goes into both 2 and 10?
2.
2. 2's a denominator. 10 is a numerator. So we can reduce them or simplify them. 2 goes into itself once, and 2 goes into 10 5 times. Now when we multiply the numerators. What's -3 times 5? -15. Do we need the 1 in the denominator? Because you got 1 times 1 in the denominator. Do we need it though? No. All right, again, preference says m equals -15 is the answer that I want boxed in. And then work letter J. What's the variable we're trying to isolate?
D.
Okay, and what do we need to move to make that happen?
1/6.
And how do we move it to the other side?
Multiply.
By
6 over 1.
6 over 1. Again, we're trying to move a fraction to the other side. Instead of dividing it, we're going to multiply both sides by the reciprocal. So the reciprocals cancel and equal 1, and D equals, see anything that'll simplify before you multiply? The 6's. 6 goes into itself once, So what is my final answer? D equals 5. Awesome. D equals 5. Any questions? Now, moving on to everyone's favorite, word problems. How many of you just absolutely love word problems with all of your heart? Okay. Be honest, they were not my favorite thing in school either. But I'm going to teach you. You can't avoid them because they're in SATs. They're going to be on your test. They're going to be in quizzes. So we can't avoid them. So let me try to help you break them down, pull out important information, and write a problem that looks like the ones we've just been doing. That's the first thing you got to understand. If I teach you a word problem at the end of a lesson and you write some kind of problem that looks nothing like what we've been doing, you've probably done something wrong. All right? So let's read the problem. Let's underline and circle the important pieces of information. It says the selling price of a certain video. All right, so let's go ahead. The selling price. That sounds pretty important, right? The selling price of a certain video is $7. Numbers are probably going to be used in our equation. So let's circle $7. It says it's $7 more than. Now, these are math words that you learned, I know, back in 7th grade. Do you remember what operation goes with more than? What is it? Addition. All right, so this is addition. So let's go ahead and put a little addition sign. It says it's $7 more than the price the store paid. So the price the store paid sounds pretty important as well. So let's underline that. It says if the selling price, look at that, there's selling price again. If the selling price is $24, find the price the store paid. Now, this is what I would do. I would highlight selling price and selling price. Because when you see the same word twice, that's a good indication that they have given you the information, the number that you need for that part of the problem. All right? So the selling price of a certain video is $7 more than the price the store paid. If the selling price is $24, find the price the store paid. So are they telling us what the store paid? Yes or no?
No.
So that makes the price the store paid our what? They didn't give it to us. It makes it our unknown, which is our variable. All right? So we're going to go ahead above it, and we'll use an X. It doesn't really matter what variable you use, but we'll use an X for this one. Okay? So now we've got to figure out what the equation looks like. So it says the selling price of a certain video. Do we know the selling price?
Yes.
Yes, it's what?
$7.
It's how much?
7.
No. Look, we highlighted selling price, selling price. What was the selling price?
24.
24. So we're now going to read the problem and we're going to fill in the information that we know. So the selling price of a certain video is $24. Okay? So the selling price of a certain video, which is $24, is, do you see this little word right here? What mathematical symbol does that word represent in a word problem? Equals. Very good. So the selling price of a certain video, which we know is $24, is $7 more than. Now be very careful. We already said this is a plus sign. But do you remember more than and less than? They are what we call turnaround words. So when you see more than or less than, you have to take whatever's in front of the word and actually put it behind the sign. So what's going behind the plus sign here? $7 more than the price the store paid. So what is in front of more than? 7, which means it's actually going to go behind the plus sign. These are the turnaround words. What are we using for the price the store paid? X. So X now is going in front of the plus sign. Now you say, Ms. Johnson, this is addition and order doesn't really matter. That is very, very true. But I don't want you to forget more than and less than. Because if you have a problem that says less than and you don't turn it around, it will be wrong. So that's why I'm pointing it out now when you see the more than. Now, does this equation look like something that we have been working on today? Yes. So now we just need to solve it. All right. What's the variable that we're trying to isolate? And what's keeping it from being alone?
7.
And how do we move it to the other side? We subtract it. Awesome. So we have x equals, what's 24 minus 7? 17. Now remember, preference says x equals 17. Now, here's my only stipulation with word problems. When you get to a word problem in your homework, I never ever make you write it down in your homework, okay? Every problem, you're giving me the original problem, except for word problems. When you hit a word problem in homework, I do not make you sit there and write it out, okay? But here's what I do make you do. You must label your answer. So we got to figure out, what is this 17? It asked us to find the price the store paid. So 17 is a what? Is a price. So what would be the label that we would put into this answer? A dollar sign, because the price is $17. If you want to write the word dollars out, I don't care. But you must label the answer to word problems. Any questions? We got one more. It says, you are loading a large pile of newspapers onto a truck. You divide the pile into 4 equal size bundles. You find that one bundle weighs 37 pounds. You want to find the weight X of the original pile. So I want you to go through, I want you to circle numbers, I want you to underline important pieces that you think you're going to pull out to write this equation. If you want to work or talk to someone near you, I'm okay with that. All right, you're loading a large pile of newspapers onto a truck. You divide. What's the first word you probably should have underlined or marked? Divide, okay? Divide, because that is an operation. It says you divide the pile into 4 equal size bundles. So what's the next thing you probably should have circled or underlined? 4. It's written as a word, but it is a number. You find that one bundle weighs 37 pounds. So one bundle by itself weighs 37 pounds. You want to find the weight X of the original pile. So if you're visual like me, visualize. You've got one big stack of newspapers. You're trying to take that stack and you're trying to divide it into 4 equal bundles. You know that one of those bundles is going to be 37 pounds. So who is brave enough to tell me what they think the equation is for this one? Raise your hand. All right, Samuel.
37 equals 4 times x. Divide by x.
Okay, all right, this is a good start. All right, but think about it. X is the weight of the original pile. So again, you've got the big tall pile of newspapers. Should I be dividing 4 by that, or should I be dividing the pile by 4?
By 4.
Okay, because remember, whatever's on the top of your fraction is what you're actually taking and dividing apart. So, you want to try that again?
37 equals x divided by 4.
Very good. All right, we got to take the original pile that we don't know yet. We don't know the weight of that original pile. And we're dividing that pile, that entire pile, into 4 equal parts. And one of them will come out to be 37 pounds. Now, could you write this? Could you have done X? Because I like to follow the story as much as I can. So for me, I would have done the whole X. I would have done X divided by 4 first, and then equals the 37. It does not matter though. As long as you're dividing the X by the 4 and you're equaling it to 37. Now, what's the variable that we're trying to isolate?
X.
X, and what's keeping X from being by itself?
4.
So how do we move the 4?
Times it by 4.
We multiply both sides by 4. So again, these 4's cancel, and X equals, what's 37 times 4? 148. But be careful. We need a label. What did we just find?
Bundles.
We found pounds. We found the weight of the original pile, right? The weight. So pounds would be your label. LBS. Are there any questions? All right. That is lesson 1.1.